checking in with you guys. I've got a few questions about 4.4 and 4.5. So I just thought I'd go through these notes with you guys. Maybe just hearing my perspective on them will help some of you guys. If it is not enough, please feel free to send me another message and I can try and go into more detail. So 4.4, matching equations and graphs. The three graphs represent the following equations. Can you match the graph to its equation? So when you have to match equations to graph, what you have to do is you have to pick points on the graph to begin with. Okay, so if I were to kind of make this graph a little bit bigger, which cuts it off, and I picked a point like 0, 3. Okay, and everyone see that that is 0, 3 right there? So if x is 0, y is 3. Is it true? So if I replace the x with 0, 3 times 0 is 0. 0 plus 3 is 3. That is correct. Would it work if I chose a different point? So if I chose a point like right here, that would be x is 1, or x is 2 and y is 1. So 2 over and 1 up, 2 and 1. Does 3 times 2 plus 3 equal 1? No? Then it does not match. Okay? If I go and take those same coordinates and put it in here, if I chose my 0, 3, does 0 plus 3 equal 3? Yes. If I choose another point, 1 and 2, does 1 plus 2 equal 3? Yes. And if I chose a third point, because it's always helpful to make sure you have 3 points to ensure that you're doing it correctly. If I go this way, I have 1, 2, so I'm at negative 2 and 5. Does negative 2 plus 5 equal 3? It does. So I can successfully say that this graph matches this equation. If I look at the second graph, okay, and same thing as I did for the first one, I'm going to go in and I'm going to pick some points that are clearly visible. So this one right here is fairly visible. X is 1 and y is 0. Does 3 times 1 plus 3 equal 0? No. So it does not work here. If I did it here, does 3 times 1 minus 3 equal 0? Yes, it does. Now, because I know that this one cannot possibly go with this equation, I know that it has to match this one. Okay, so when you are matching equations and graphs, sometimes it is just easiest to pick 3 points and put them in. Now, if you actually go through, what I had done is I had filled out all the actual notes for you for substituting 0 for x, 3 times 0 plus 3 equals 3, and showing the different coordinates that actually could happen, and then going up into my graphs and matching the coordinates that I found to the graph to see which one it actually belonged to. So if we go and try these ones. So step 1, you can make a table of values, or like we had just did, you can go and look at your graph. So if I'm going to start with this graph, which I believe is graph A, I'm going to actually pick a point that's on my graph. So if I pick the point that's right over here, I don't know why I have this weird shape thing. There we go. So we've got 3 and 6. So if x is 3, does it equal 6? No. Does 2 times 3 equal 6? Yes. Does negative 3 times 2 equal 6? No. So that clearly means that graph A has to belong with my second equation. Now I think can I write on here? Maybe not. I'm not that skilled with this part. Insert. Drawing? No, not drawing. Yeah, I'm not seeing what I need to do. Okay, nope, cancel. So y equals 2x goes with graph A. Okay, so that one's out. Cross it out. I wish I had a marker. Okay, so y equals x. So now that I've looked at graph A, I'm going to pick a point on the next graph. So this would be graph C. And if I pick a point, so this is 4 and 4. If x is 4, is y 4? Well, yes, that's true. Will that work if I picked a different point? 6, 6? Yes. And if I chose another one, -4, -4, yes. So graph C goes with the first one, which means that graph B has to go with the last equation. So I'm going to let you guys try and figure out this one. Can you match it? So same concept, pick a point on the line, put it in, and see if it works. Hopefully this was helpful for you. If it wasn't, please send me a message back.